The specific problem that we'll be interested in solving in this lecture will be the problem of reliably broadcasting a message in the presence of Byzantine failures of processes. So, broadcasting a message is particularly problematic in Byzantine environments. And this is for the several reasons. So first, a Byzantine process can forge the payload. So the application may invoke broadcast event with some message argument, but Byzantine process can substitute it with something else. So these types of attacks can actually be dealt with to some extent at the application level by, for example, ensuring that we include enough information into the message payload and perhaps also authenticate it cryptographically so we can identify or distinguish legitimate payload from the forged one. However, this still does not prevent the following problem, which is called the problem of equivocation. And if you search the internet, in particular various forums where people are discussing blockchains and digital currency, you will see that this is one of the problems that people are frequently talking about. And in the equivocation attack, a faulty sender may distribute different payloads, which actually may look legitimate, to different processes while pretending it to be the content of the same broadcast request. So what happens here is that application requests the Byzantine broadcast primitive to distribute a specific message, and instead of doing that, the sender may, for example, send this message to a subset of processes and a different message with the legitimate payload to another set of processes. So it may equivocate. And this is a problem specifically for leader-driven algorithms, such as consensus. And as we discussed, consensus plays an important role in implementing digital currencies. So this is why equivocation is frequently discussed in conjunction with digital or cryptocurrencies. So in a leader-driven algorithm, we fundamentally rely on the ability to distribute a proposal, a consistent proposal, to multiple processes. And this fundamental ability is fundamentally undermined by equivocation. So Byzantine reliable broadcast abstraction that we are going to consider actually deals with this problem of equivocation. And it also, to some extent, may prevent forgery in the sense that it would prevent Byzantine processes from forging a message if this message was actually broadcast by a correct sender. So it does provide some form of authentication.